Good evening, folks. I forgot to find what we're looking for. We're actually supposed to calculate or find S. Now, a lot of you are familiar with this kind of problem. Recognize S is minus the sum of the roots of this cubic equation. We will also be able to find D after we're done, but I just said, just in the sake of brevity, we'll just find S. Okay. Now, S and D are specified to be rational, although I'm not sure you even needed to do that. I think it just works out that way. Now, it works out whether or not you assume that they're rational or not. What we do know is that it has three distinct positive roots that are consecutive terms in an arithmetic progression. Now, down here, I've assumed that those roots are A, B, and C. And so what we do know is this, is that the very first root would be equal to A. The next root would be A plus D, where A is this A plus 2, I guess. Okay, since the common difference is 2, and then A plus 4. So that's quite a bit of structure, actually. The very first root is an unknown A. The next root is A plus 2 and A plus 4, and that's because the common difference is specified to be 2. Okay? Now, this would just be called B, and this would just be called C as far as the way this is developed down here. And what I've done, this expansion just shows you the justification for Vieta's formulas, how minus the sum of the zeros presents as x squared. And you have the products of the pairs, their sum is presents as the coefficient of x, and minus the product of the zeros is the constant term. Okay, now, the reason why I did it this way, and y'all, the way I'm doing this down here, of course, D would be 2. I just wanted you to see the structure of it. D is 2, the common difference is 2. That's just given to us in the problem. Now, also another thing that is quite important here is that 343, and I'm sure a lot of you have seen it, but that's equal to 7 cubed, right? And you'll note that 343 and 636 are relatively prime, meaning that this fraction is reduced. Okay, so it's very reasonable to suspect this would be the structure of A, B, and C. And also, if we get an answer that checks out, it's good whether or not we can justify this at this stage. But I think this line is completely justified right here. Notice that 7D over 7 is just D, 14D over 7 is just 2D, just like we right up here. Okay, so let's keep going. Now, at this point, we're just equating coefficients. The product of the roots, okay, is this number right here, and that's because maybe I should have written a little bit more up here. You see how you have minus ABC is equal to minus this? This part right here would imply that ABC is equal to, ABC is equal to that constant term, 6336 over 343. Okay. Now, and also, let's see, what else do we have? The sum of the zeros, it's not important. This is the only concrete number that we're given, okay? So you see, we've gotten this far, and what's nice about the setup that we have right now is that you can observe through properties or divisibility rules that 2 is a divisor of this, 3 is a divisor, and 11 is a divisor. Now, I would like to say this is a 4-digit palindrome, so it's divisible by 11. Another reason why it's divisible is 10 to the n is always congruent to -1 raised to the n power, mod 11. So there's a divisibility test that helps you establish that this number is indeed divisible by 11. Okay, now this would be -6 plus 3 minus 3 plus 6 is 0, and 11 is a divisor of 0. All right. Now, if you do a little bit of work here, it takes some time, you'll get 2 to the 6th. And this is really the major computation in the problem. Times 3 squared times 11 is the numerator here. 6336 is this prime factorization. And I've done something here that I think, hopefully you'll think, I thought this was really pretty cool. What I've done is I've lined up the possibilities. You can also conclude that R must be even. R is even. Should have said that earlier, but hopefully you can see why that's the case. The product of R times R plus 14 times R plus 28 is an even number. And if R was an odd number, this would end up being an odd number times an odd number times an odd number, right? So R is even is a nice assumption. Now, another thing to note here is that we have 7 times 3 times 2 divisors. What is that, 42? So you see, folks, we have 42 divisors. Y'all remember the result. If you look at the exponents and increment each of the exponents and multiply them, you get the total number of divisors, okay? So that's a lot of divisors to check, but at least we know that R has to be even. So let's start out, okay, and see what we can do here. To me, this is an interesting approach. You know, we're not given too much information up here, right? We're given one constant term and everything else is unknown, essentially. And the fact that it's an arithmetic progression gives us just enough structure to play a little bit of a guessing game here. We know that R is even, so the very first even divisor would be 2, right? Now the next even divisor would be 16. And then the next even divisor would be what, 44? Or no, 2 plus 4 is 16. And then 2, this would be 30, right? Now notice that none of these have a factor of 11. You see 11? And 11 has to be accounted for, right? Because this is the product of all of these prime divisors, right? In other words, R times R plus 14 times R plus 28 has to equal to 6336, okay? And we got this circumstance here. 2 is an even number, but none of these factors include the divisor 11. So I'm going to mark X here. It's not possible, right? Again, I think it's very cool. So what's our next even divisor? Well, we have all kinds of 2's here, so the next even divisor would be 4, okay? And then in turn, just like we did last time, we'll get 18 here. All right, and then 32? And once again, this isn't possible because none of these, you have a divisor of 3 here, and the rest of it's just divisors of 2, right? So again, we're missing the factor of 11, so we have to say not possible. Okay, what's our next even divisor? 6, right? Remember, 2 and 3 are in the prime factorization, so 6 would be a divisor. 6 plus 14 is 20. Now notice this has a divisor of 5. Already we could stop because there's a divisor of 5 here. See, we don't even have to do the next one, right? Because 20, R plus 14, R plus 14, where are we at here? Okay, I lost the spot here, folks. We'll be back in a minute. Okay, so this is equal to 4 times 5. All right, and notice that 5 is not in the prime factorization. So without even computing R plus 28, we can say this is impossible, right? So not possible. See, we're not doing direct calculations. We're just comparing to the prime factorization. That is cool. All the work was done finding the prime factorizations. So let's check out 8. R equals 8. All right. Now, so 2's here, R 8 plus 14. Now, this is good news because this is 22, which is equal to 2 times 11, right? it's looking really good right now because we have our first factor of 11, and that's what we're looking for because 11 is in the prime factorization up here. Okay, now what about this next one? That would be 8 plus 28, which is 36. Okay, now notice that 36 is equal to 2 squared times 3 squared, right? You see, we're just trying to account for all the prime factors, folks. This is equal to 2 cubed. And lo and behold, we have, you see, we have 3 copies of 2. Another copy of 2 is 4. So we have 2 to the 6. You see, 2 to the 6 is required. And then also notice that we have 3 happening twice just like we need. And then we do have 11 right here, right? So this has to be our answer. And now what does that mean? That means that 8 over 7 is one of the roots. We'll call it A if you want to. A is equal to 8 over 7. B is equal to 22 over 7. Finally, C is equal to 36 over 7, right? Now remember, what are we looking for? Okay, we know what A, B, and C are, and we also know that minus, right up here, minus A plus B plus C appears right here as, see, we're trying to find S, right? So this is the same thing as S right here, x squared. So minus A plus B plus C is right here. So that's what our S will be. So in other words, what we'll get, let's see if I can remember these. 8 over 7, 8, 22, and 36. So what we get right here, folks, is A is equal to minus 8 over 7 plus 22 over 7 plus 36 over 7, right? And let's see, what does this add up to, ladies and gentlemen? 30, that's equal to minus 66 over 7. Now, y'all, I'm kind of fascinated by this problem type because it was tedious, shall we say. But, oh yeah, and by the way, before I continue, notice you could calculate S very easily because S is just going to be, you'd have to multiply AB together, AC together, and BC together, and you could get S also, or D. I'm sorry, D. My bad. We just calculate S, but you could get D just by looking at this right here. This would be your D. All right, and you know what A, B, and C are, so you would get it done. I just wanted to save a little bit of time. But y'all, what I like about this problem a lot is we didn't even know the coefficient of x squared. We didn't know the coefficient of x. All right. And so essentially what happened, all our work went into calculating the prime factorization of 2 to the 6 times 3 squared times 11. And also it did help to note that R was even, right? R has to be even. That's a big help. Otherwise, we do have quite a few odd factors, don't we, here? A bunch of odd factors, right? 3 times 11, 11 itself, 9 times 11. So we didn't have to check any of the odd factors. We just started checking even factors until we ran into the one that works. And I guess technically you had no assurance you were ever going to run into one that works. And also I haven't proven this is the only one either. I've just found one. There may well be others. I'm not certain because we have plenty of other. We could check 16 next, right? There's all kinds of 22. We could check 22 as our first one, I think. I'm pretty sure this would be the only positive solutions here. But in any event, we did find one. And I was careful about the way I worded the instructions. I said find S, which is a little misleading. I think this is the only S right here. I could be wrong. But anyway, let me know if you see more. But again, it's fundamentally different than a lot of problems in the sense that the prime factorization calculation was everything here. Of course, there was other things going on, but we never even had to check anything other than would it be possible for these combinations to be an answer. All right. And once we found one where it was possible, all that adhered to the structure, we knew we were done as far as finding at least one. So anyway, that's all. Again, S is equal to minus 66 over 7.